Tegra Medical has a long history with TruClear tissue shavers. These are the TruClear tissue shavers. They are used for hysteroscopic tissue removal, including myomectomies, polypectomies, diagnostic visual D&C procedures, and endometrial biopsies. This type of tissue removal represents the gold standard for the diagnosis and treatment of intrauterine pathologies. These types of devices make up a huge portion of Tegra Medical's business, with our largest customers forecasting huge growth, including Medtronic, Arthrex, and Hologic. Tegra Medical has a long history with the TruClear product. Originally developed by Smith & Nephew in 2009 with Tegra Medical doing a small portion of the manufacturing steps, it was purchased by Medtronic in 2016 and the entire metal production awarded to Tegra Medical and the plastic spin welding of the handle components given to Viant. In 2019, Medtronic then began development of the next generation product, Caravan, and awarded this product from metal to plastic overmolding to Tegra Medical alone. The Dynamite Shaver was developed in 2020, with Tegra Medical awarded the business to manufacture the inner assembly, including plastic insert molding and packaging. In the third quarter of 2021, Tegra was notified of extreme demand increase for the incisor assemblies due to the market demand increases and a change in Medtronic's inventory strategies during COVID. Tegra implemented a few different strategies in an effort to meet this increased demand. We created a project team to support the ramp-up, whose first goal was to initiate process improvements and reduce inspections during the manufacturing process. The team also worked with external suppliers for improved capacity initiatives. The long-term goals were to design and build a laser welding automation system that would eliminate manual loading of individual components and greatly increase throughput at one of the biggest bottlenecks of the process. This would also reduce the amount of straightening post-weld due to increased quality. The directional forecast looking forward to 2026 is only increasing, even as the next generation product Caravan cannibalizes the legacy TruClear product. Total revenue shows huge increases through 2026. When the project team analyzed the process flow of these products, the welding process was identified as the major bottleneck in the process. The current welding process has an operator manually load the deep-drawn tip and tube into the lathe. A single laser tack welds in two places at 180 degrees, then does a 360 weld along the seam. The operators check the ID of each part with a mandrel to ensure there is no ID occlusion and can produce about 65 parts per hour. Due to the single tack weld, straightness is an issue with this process. As a result, the parts are 100% inspected and straightened in our secondary department. The current run rate for this process is about 81 parts per hour. The historic demand for the 4 part numbers that use this welding method is 19,800 parts per month, which has a resulting planned hours per month in laser of 311.9 hours and 220 hours in secondary straightening. With the increased demand, the number of units increased 59% to 31,350 pieces, ballooning the welding hours to over 500 and the straightening hours to over 350. In order to increase throughput for the main bottleneck, the team decided to explore automating the welding process. The team identified the benefits of moving to an automated welding process, including very good quality with minimal variation, very high throughput due to automated handling steps that can happen simultaneously to welding, and a reduced footprint. One automated machine would have the same capacity as 3 to 4 manual systems. This diagram shows the process steps of the automated process. The tip feed, tube feed, and straightness inspections would happen in parallel to the welding, resulting in greatly improved throughput. The straightness inspections would sort good from bad parts, and only the bad parts would need to be manually straightened. There are many benefits to the automated welding solution, one of the most important of which is quality. The 3-tack laser system improves the straightness yield, and the straightness inspection is done as part of the process. All alignment of parts is verified by camera inspection. The robot arm's motions are highly repeatable, and it does not make any adjustments or try to improve things, one of the main sources of variation in a manual process. All this results in a greatly increased throughput and quality of TrueClear product. The operator running the machine will load tips into a vibratory hopper and bowl that will align and feed the components to the robot for pickup. Likewise, the tubes are loaded in bulk and then automatically presented one at a time to the robot arm. Sensors allow for precise presentation of components to the robot, creating a highly repeatable process. The dual gripper robot picks up both components at the same time for increased loading speed. The 3-laser system greatly reduces variation in straightness, which is inspected 100% at the straightness gauge after welding. In order to improve straightness between the tip and tube, the automated welder uses 3 lasers to tack simultaneously, greatly reducing any shift in alignment that is seen with a single tack weld. The next slide demonstrates the automated welding solution and its benefits. The tips are fed through the vibratory bowl and presented to the robot arm, which picks up the tip and tube in the same motion. These are then loaded into the welding fixture with placement verified by automated camera inspection. The 3 lasers then fire to tack in 3 locations, followed by a 360-degree tack weld by 1 laser. The welded assembly is then picked up by the robot arm and another tip and tube loaded for welding. The assembly is then dropped into the straightness inspection gauge and sorted. Only parts with out-of-spec straightness are straightened in the subsequent secondary operation. The automated process projects to have a 67% increase in throughput. Preliminary results show that only 38% of parts are rejected off the automated process for straightness, which would result in a reduction in secondary hours by 62%. This results in huge savings on an annual basis. The current manual welding process uses an annual headcount of 4.9 at a cost of $523,708 per year. With the automated welding process, the headcount is reduced to 65% to 1.7 at a cost of $222,131 per year, a 57% reduction. Tegra Medical Franklin is extremely excited by the opportunity that automated welding provides. Not only will it reduce required headcount for TrueClear product by a projected 3.2 operators and result in over $300,000 in savings, but it frees almost 4% of manual welding capacity. Tegra Medical Franklin is extremely excited by the opportunity that automated welding provides. Not only will it reduce required headcount for TrueClear product by a projected 3.2 operators and result in over $300,000 in savings, but it frees almost 4% of manual welding capacity, which has traditionally been a major bottleneck in most manufacturing processes due to the nature of the process. Additionally, the capacity of the automated welder far exceeds the TrueClear demand, allowing Tegra to expand capacity on other constrained products that have a similar tip-to-tube welding application. Thank you for your attention. We hope that you are as excited as we are about the opportunities this welding application gives us.